Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through rings. So rings are sets that take the idea of a group a bit further. So let's look at this set here, Z4, which is the set of integers modulo 4, which turns out to be a ring. So we've already established that Z4 is a group under addition. So why is that? What does it mean to be a group under addition? Well, first and foremost, we can see from this table that the integers modulo 4 are closed under addition. You add together any two of them, you get another member of the set. We also established that addition was associative. It can take a while to prove that. It sort of follows from the real numbers. We also have established that each element of the group has an additive inverse that is also part of the group. So the additive inverse of 0 is 0, of 1 is 3, of 2 is itself, and of 3 is 1. So because of that, because it's closed and inverses are part of the group, we also have that the additive identity is part of the group. So Z4 forms a group under addition. In fact, we established that it formed an abelian group under addition. So in order to be a ring, the set has to form a group under addition, but it has these additional axioms here. So it also has to be closed under multiplication, and we can see that here. If you multiply any two elements of Z4, you get another element of Z4. So it's clearly closed under multiplication. We also need to have that multiplication is associative. We established that before. Again, it's pretty hard to prove, but we know it's true. And finally, we also need to have that the distributive law applies. So for any elements A, B, and C that are members of this set R, it needs to be true that A outside of B plus C equals AB plus AC. So we've seen the distributive law. We know it applies to integers, to real numbers, and any subset. It turns out that it applies here. So we could easily prove that the distributive law applies here, but it would be a bit tedious and we need to check lots of different combinations. So I put this statement here because this one can be a bit confusing. Do rings need to include the multiplicative identity? Some textbooks say yes, some say no. I don't really mind which definition you use, but I just wanted you to be aware of it. So sometimes you'll be told that a ring must contain 1, the multiplicative identity, sometimes it won't be. But in any case, this set clearly contains the multiplicative identity 1. So Z4, set of integers modulo 4, is clearly a ring. It's a group under addition, but it's not quite a group under multiplication because rings are not required to have multiplicative inverses. But in addition to that, in addition to those axioms, the distributive law also needs to apply. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.